Welcome to our talk toward a synchronized manufacturing digital twin. In the following 10 minutes, we'd like to give you an idea about the challenges of a globally distributed team of manufacturing planners. We'll show how tools like ipolog and NVIDIA Omniverse can help out to address these challenges. Please feel free to post your questions during the presentation. We'll answer them in the Q&A section. Before we go into the presentation, I'd like to thank all the great people who were involved in preparations for this talk, beginning from my co-presenters Nadine, John, and Julian, my colleagues Caro and Thomas, as well as our advisors Matthias and Wolfgang, and last but not least, the great team of NVIDIA for their tremendous support. Thank you so much. So let's begin. So I'm Miachel Wagner, CTO and co-founder of ipolog. And to get you a little more immersed in the manufacturing planning world, I've asked my colleagues Nadine, Julian, and John to meet here for a virtual manufacturing planning call. We're just dialing in. Nadine's coming.
Hello, everyone.
And Julian.
Hi there.
And John.
Hello.
Thank you all for joining. So let's maybe do a quick round of introduction first. Nadine, if you'd like to start.
Hi, I'm Nadine Wollinsky. I'm the head of integration and consulting team here at ipolog in Leonberg, Germany.
Welcome. And Julian.
Hi, I'm Julian Winzer. I'm the product owner for logistics planning systems at BMW Group.
And last but not least, John.
Yes, my name's John Mitchell. I'm the project lead for virtual factory planning here at BMW plant Spartanburg in the US.
So thank you all for joining. Before we go into details, Julian, could you tell us a little more about BMW and the motivation to work with digital twins?
Sure. To give you an idea about our motivation to build up a digital twins of our plants at BMW, here are some figures. BMW has 31 factories in 15 countries around the world. Over 110,000 colleagues of mine and approximately 12,000 suppliers in about 70 countries made it possible that BMW sold 2.5 million vehicles in 2021. To achieve such amazing results, the best quality and on time, we count on planning tools such as ipolog. I'm based in Munich, Germany, and one of the tasks in my role as a logistics planner is to plan our production logistics within tools from ipolog. I'm happy to work together with colleagues from all over the world, such as John and Spartanburg. John, maybe it's best you tell yourself about your current role.
Right, Julian. As you can see, I'm here at our factory site in Spartanburg, where we proudly produce the BMW X models, as well as the performance models for each of these vehicles. I work closely with Nadine from ipolog in Germany, and she's helping me out with detailed rack construction.
My pleasure, John. I'm located here at the ipolog office in Leonberg, southern Germany. My role as BMW Key Account Manager is to support our customers like John and Julian. For example, I'm helping them to create ipolog scenarios or by constructing racks for material provisioning using a CAD engineering tool.
Thank you all. So to wrap up, we've got a globally distributed team working in different organizations and using different tools. So how can a holistic digital twin help us here? We'd like to illustrate that with a use case which is pretty common as a planning task for car factories. Let's suppose BMW introduces a new product variant to one of their models. We've got new or different parts coming in, or even new technologies, if you think of electrical vehicles, for example. This has a lot of implications on the manufacturing process, right, John?
Right. Let's look at the Spartanburg manufacturing site. It's not our largest production site, but we're building approximately 1,500 cars a day with 11,000 colleagues on around 7 million square feet. This means for our material flow, we have to move over 4,000 different materials, resulting in over 160,000 transport orders each day. When we introduce a new product variant, there are a lot of changes in the production process. Depending on the product variant, we may have to mount different additional parts, which have to be provided at the assembly line. But not only this, we have to change our logistics processes, which ensure that the right material is delivered at the right time and at the right spot. Before a part is actually reaching the assembly station where it's needed, it may have been processed several times in upstream stations. Therefore, we have lots of dependencies and interactions between planners.
Wow, that's quite a challenge. Here we can see a visualization of the transport orders of one day throughout the factory. Each little block represents the need for a certain material delivered to a processing station. We have to handle constant changes in the production process due to different production programs and product variants produced. Of all the changed materials, let's focus on one small use case of 3 additional materials needed in a station of an assembly line. What would you do about that, John?
Well, I would start by opening the station in my ipolog for workspace tool. I've linked the surroundings from the nucleus so I can ensure that the layout is up to date and all relevant blocking areas are visible. Let's say we have 3 new materials to provide. Let's put them into a new rack by creating a simple rack requirement representation and let Nadine work out the construction details. So let's share this with Nadine. Let's push our planning state to the nucleus and ask her to help us out. Here we can see the new rack requirement in the real environment. Nadine, how would you then continue?
Let's have a look at it. Since you've granted me access to the ipolog requirements in the nucleus, I can easily create the rack construction according to that. Whenever you change something in the requirement, I can see it and react on it. So let's create the detailed rack construction using our CAD engineering tool, just like that. Now let's push our construction to the nucleus, replacing the requirement model with our nice CAD model. Yes, that looks way better.
Thank you, Nadine. But the additional rack is not the only change. Upstream logistics processes have to be adjusted as well to deliver the additional material to the station. We can use Omniverse backend services like the NVIDIA Reopt scheduling service to support us there. They can act automatically on scenario changes and quickly verify that all logistics boundary conditions are met, like the amount of available transport resources for a given point in time. NVIDIA Reopt, as you see here, is an AI logistics SDK that enables near real-time routing optimizations, and we can leverage larger data sets and faster processing. This enables new capabilities like dynamic rerouting and simulations. So Julian can use this information for his overall material flow plan. Right, Julian?
Yes, indeed. I could integrate the proposed changes with my overall logistics process plan in ipolog material flow, but let's see. See, that makes sense. We can adjust our supply chains to take that provision change into account and update our overall material flow concept. Let's check some other KPIs if everything will be fine. I could even push the updated plan to the nucleus where it would be available to our logistics service providers. They could update their scheduling and let their autonomous transport robot fleet do the work. Here we see how a mobile robot is changing the rack with a new material set, which is delivered in the sequence, for example.
That's awesome, Julian. But as we all have seen, we can do most of these things already in Omniverse. We can rely on a consistent layout, do in-place equipment construction, use reactive backend services, and synchronize upstream processes, which makes our life a lot easier. Now we've seen the tasks related to just one tiny little use case in the logistics domain, one of thousands. But imagine if we take it even further, if we extrapolate these efficiency and productivity gains to the complete product lifecycle and moreover to value chains with part and equipment suppliers, we're at the verge of a manufacturing metaverse, enabling perfect products without waste. But to be a little more concrete, we estimate that 80% of all regular coordination meetings can be discarded or extremely streamlined because the information is already available when and where it's needed. We also think that project turnover over time can be optimized by 30% due to shorter planning iteration cycles. And finally, we think that this could contribute to 10% reduced production costs per product due to a better overall planning quality and streamlined production processes. For more information, please visit our website. Now I'd like to thank you all and my co-presenters. We're happy to taking your questions.